Good morning, everyone. Good morning, students. Good morning, teachers. Today, we are going to discuss about solving linear equations using the Gauss-Jordan method. So, suppose we are given 3x plus 5y minus 2z equals 10, 2x plus 3y plus z equals 5, x plus y plus z equals 4. So in elementary algebra, we use either the elimination method or the substitution method, no, in solving for the values of x, y, and z. And we call this lesson in elementary algebra as systems of linear equations. Now, in linear algebra, we have an alternative in solving for the values of x, y, and z. So the first thing that we're going to do is determine now our coefficients. So the coefficients here are, if you cannot see a number, obviously that's 1, 3, 2, and 1. The coefficients here are negative 5, 3, and 1. And the coefficients here are negative 2, 1, and 1. And of course, creating an augmented matrix now. So we have here either the dots or the columns, or you can directly write this way. Okay? So we have 10, 5, and 4 are also copied. Now, our goal here, in order to determine the values of x, y, and z, is to come up with or to arrive at the identity matrix. Okay, so wherein we have the diagonal, no? 1, 1, 1. So 1, 0, 0, 0, 1, 0, and 0, 0, 1. Okay, so whatever is the value or the outcome, no? When this becomes the identity matrix, no? Whatever are the values here, no? Respectively will be the values for x, y, and z. So the first thing that we're going to do is to make this value equal to 1, such as this. So to do that, we simply multiply it by its multiplicative inverse. Its multiplicative inverse is 1/3. So it's not only this number, but we have to multiply it to the remaining elements of row 1. So 1/3 of 3 is 1. 1/3 of negative 5 is negative 5/3, and 1/3 of negative 2 is negative 2/3, and 1/3 of 10 is 10 over 3. Now you see that the first row, first column is now equal to 1. Okay? So our next goal is for this to be equal to 0, no? Siya, 0 also with this. Okay, so why not according to rows? So it should be according to the first column, second column, third column, no? So we start with the first column, followed by the second column, then followed by the third column. Okay, so how do we make these values equal to 0? Now you are going to use 1 here. Okay, so what makes, or simply determine, no, the inverse, the additive inverse of 2. So, a while ago, we used the multiplicative inverse in order to make this equal to 1, which is the identity element for multiplication, no? Now, what is the identity element for addition? It's 0. So, what is the additive inverse of 2? So, it's negative 2. So, you are going to multiply negative 2 in R1, which is 1. No, 1 of which is 1. The leading coefficient is 1. So, negative 2 times 1 plus row 2. Okay? So, we have the formula here, negative 2R1 plus R2, or negative 2 times your row 1 plus row 2. So, if you're going to do that operation, see to it that you're also going to do that to the corresponding values here. Okay? So, how about the third row? What is the additive inverse of 1? The additive inverse of 1 is negative 1. So, you multiply that negative 1 to 1 here so that it becomes negative 1, and then add it up to 1 to make it 0. So the formula is then negative R1 plus R3. Okay, so I'm giving you here the very systematic way of doing the Gauss-Jordan method for beginners. Okay, so there are other formulas that you can use, no? You can actually play with it, explore with the arithmetic. But this, I'm going to teach you only the very systematic procedure such that it would be easier for you to understand, and then you can develop already the system, no, or the technique, no, makuha na ninyo ang technique. Okay, so notice that negative 2, let's start with the first operation. Negative 2R1 plus R2. So negative 2 times 1 plus 2, that becomes 0. Now, the next one is going to be difficult because it involves fractions. So those who are confused with fractions would be having difficulty with this. So if ever, you can use the fraction key of your scientific calculator so that it would be easier, no, to come up with the correct answer. Now, we have here negative 2 of negative 5/3. So negative, we're actually negative 2 times negative 5/3, then plus 3. Okay? So negative 2 of negative 5/3 plus 3. So this is what we are going. We are doing. So negative 2 times negative 5/3 plus 3 is negative 10 over 3 plus, this becomes 9 over 3. I hope you know that. Now, going back to your elementary days. So that's 3 times 3 is 9 divided by 3. So now that they have the same denominators, you can directly add 10 and 9 so that you come up with 19. So you have 19 over 3, which is now the value here. Okay, next is negative 2 multiplied by negative 2/3 plus 1. Okay, so this is the operation now. Negative 2 times negative 2 is positive 4 over 3, and 3 times 1 is 3 over 3. So you have 4 and 3, which is 7 over 3. Okay, then the next thing that you're going to do is multiply again negative 2 by 10 over 3, then plus 5. Okay, so negative 2 times 10 is negative 20 over 3, then 3 times 5 is 15, so you have 15 over 3. Negative 20 plus 15 is negative 5 over 3. So that's the value here. Okay, so let's move on to the third row. So the operation is multiply negative 1 by negative 5 over 3, or simply negative of negative 5 over 3 is positive 5 over 3 plus 1, which happens to be equal to 3 over 3. So we have 5 plus 3 equals 8 over 3. Next, negative of negative 2/3 is 2/3 plus 1, which is 3 over 3. So you have 5 over 3. And then, negative 10 over 3. Alright, that's the product of negative 1 and 10 over 3. Plus 4 is actually negative 10 over 3 plus 3 times 4, 12. So 12 over 3. Negative 10 plus 12 is 2. So 2 over 3 is the outcome here. So, what's next is, again, you have to recall the identity matrix. So, 1, 0, 0, 0, 1, 0, and 0, 0, 1. So, next time is the second row and second column. So, this one, you are going to make this equal to 1. So, how are we going to do that? We simply multiply 19